Uh, Good afternoon, everyone. Hope everyone was doing well and had a great Thanksgiving holiday, getting ready for Christmas. Some of the comments that I got back from Nick in the group was that we want to talk about DDC controls, but more in a lower cost, lighter application type function. So put together a presentation, wanted to talk about some of the stuff that's out there now in the market for direct digital controls. Let me do this real quick and share my video. Give me 1 second. There we go. Okay, so what I wanted to do is talk about some of the lighter controls that are in the market that are a little more affordable, right? So what we want to try to do is provide a system that's within a budget, right, for a smaller application, lighter application, but still be able to provide a lot of the features that DDC systems offer. So some of those features, operation efficiency. So a direct digital control system gives you a little more efficiency than a standard electromechanical, even a programmable thermostat. And there's just a little bit more built in from a logical standpoint on the DDC side with the thermostat capability that's out there now. The biggest thing is access and control flexibility, right? Not having to walk around, or an occupant or a tenant or a building owner having to walk around and look at every single thermostat or touch everything in the facility to make sure that it's working, it's programmed correctly, it's scheduling, those types of things. So access and control flexibility is a big piece. Logical control in place of electromechanical, right? We talk about proportional versus PID, or proportional integral derivative, right? Proportional is most thermostats. You put a set point in, you've got a deadband. You're looking for that thermostat or controller to control to that deadband. It gets there, shuts off. You've got a time delay, turns back on. There's not a whole lot of functionality built into proportional only, right? So when you bring in the integral and derivative side, you now can look at what happened last time at the same temperature, at the same ambient temperature, those types of things. And there's a lot of efficiency that can be added with a DDC thermostat versus just standard programmable thermostat. We'll talk a little bit about that as well. And then other information that can be brought in, because we might have a little more IO, inputs and outputs, things of that nature that we can bring in to a DDC system versus a programmable thermostat about the facility, not necessarily just about the equipment, right? Increased maintenance and troubleshooting is a given, right? If we can see it and we can see everything at once, then we could see what's wrong with it. We can troubleshoot it, we can trend it and do those types of things. And then once you have a system in, whether it's a light system or not, we have some kind of a communication protocol or method, whether it's a wired method, a cloud, internet connection, Ethernet connection to the system. So we have the ability to expand on that in the future for other applications in the building. Okay. So what are our goals, right? What are our goals with the light system to add DDC into a facility, right? A couple of options and a couple of products that are out there are communicating and wireless thermostats. I think everyone's used those either at their house or in commercial applications. So I want to get into what that capability is, what's happening in the field, and what's happening in the for the future of this product down the road from an installation and from a control sustainability standpoint. So we'll talk about that. What about zoning applications? One of the things we get into constant volume and variable air volume zoning is it's not always the least expensive application for DDC systems, but there are some low-cost zoning applications out there. I want to talk to you about those as well. Some light applied system applications. Applied doesn't always have to be, chilled water, hot water. Applied can be, specific applications for lead lag control, specific applications for hot water monitoring or measurement control, those types of things. So let's look at that as well and what we can do at a low cost or a low budget offerability. And then affordable integration. There was a couple of questions I saw on the sign-up sheet about integration for VRF and some other things. So I wanted to talk to you a little bit about that and some of the lower cost options for doing that type of integration on either existing facilities or new equipment. Okay, so the thermostat's a thermostat, right? Not necessarily. So DDC systems give you a little bit more control, right? The interconnection to it is really the big piece. How are we going to connect to this building? How are we looking at what this thermostat is providing us, how this thermostat or how this area is performing based on what that controller is doing, right? There's additional operation data we talked about, right? Addressable features, DCV, demand control ventilation, things that we're doing with outside air, especially in the Southeast. We want to know what that outside air condition is before we bring it in. Latent capacity control, we're doing a lot more dehumidification with thermostats now, not necessarily just DDC control systems. And then adaptable control features, such as looking at, recovering from ambient conditions that are unusual. We've seen a little bit of that lately too, where one day it's 80 degrees, the next day it's, 55. So how does a system perform based on those ambient conditions and those changes in the climate, not only outside, but inside the facilities? DDC controls have a little bit more opportunity to fight that type of a condition than a programmable or even a non-programmable thermostat. Trending and reporting for troubleshooting, and then multiple vendor support. One of the things that we're seeing in the market these days, especially in the the North American market, is Bacnet is really taking over as the protocol. And so we'll talk a little bit about that, Bacnet and some of the other protocols as well. But most vendors have a product that has an open protocol now. And the ability to have multiple, even thermostats sitting on the same bus or the same network is certainly capable nowadays. Okay. And the reason for that, really, for multiple thermostats is I might have certain applications that don't lend itself to the same product in the same building. So I want to be able to be flexible as to what I provide. So if you look at the market, what that target market is, right? So DDC systems, the larger scale DDC systems, plants, industrial centers, large, schools, colleges, universities, those type of things, hospitals, healthcare, those types of things where we're seeing a larger application. It's chilled water, it's hot water. Nowadays might be some more VRF, but it's usually a larger scale application where we're up around, okay, we're going to have a front end. We have to have connectivity. A lot of these applications in the facility need to connect together. But there are areas that really, even in that DDC large scale application, like a school, that we're starting to look at, okay, well, what if we start using thermostats? So what if we start using lower IO to do the things that we were doing with larger scale applications in the past? So there's definitely a market that is there for those types of applications, and even down in the higher end residential area. Okay. So wiring is pretty much the same. The nice thing about using communicating thermostats, whether you are doing a wired bus or whether you're doing something with a cloud or a Wi-Fi application, you're still connecting the thermostat to a piece of equipment the same way you would in the past, or if it's a non-programmable or a programmable thermostat. That wire stays the same, right? Nowadays, there are some systems out there where you don't even need wire to the equipment. Got to be careful in those applications because wireless, Zigbee or an Ocean, the different protocols that are out there today still have some susceptibility to water, to concrete. There's lots of things, mirrors. So it depends on what type of an application you've got. You just still have to be cognizant of what's in that facility, what could drop that signal out. So having a non-wired connection from a thermostat to a piece of equipment, though there are available options and capabilities out there, just be aware of what those obstacles might be to try to get that information over the piece of equipment. So the wiring is the same. If it's a connected system, it's usually going to be what we call Bacnet Mstp. Okay, Bacnet Mstp is a 2-wire COM bus. that runs, and it's mainly used in DDC applications, but it can be used for thermostats as well. Bacnet thermostats can run a 2-wire COM bus between the thermostats, and now you have a connected system. Okay, very similar to a wireless mesh. However, it's a piece of wire instead of a Wi-Fi type application. So a lot of systems are now using cloud, or you can do on-site monitoring and access control as well through self-controlled systems, hubs, and things of that nature, which we'll talk about. Okay, you have the capability to add remote sensors, so you're not stuck with just the thermostat. And a lot of thermostat, even non-DDC type thermostats, have that capability, but DDC mainly does on every application or every vendor you're going to use. You have the ability to do multiple sensor monitoring. And then easy programming, right? So I can program this guy up top, and it can send its program down to other guys in the field. So I can program one thermostat, add all my other thermostats online, clone the program, and I've got a capable system right off the bat. Okay, let's talk about Bacnet Communications. So a Bacnet connection is either one of two. It's either MSTP, multi-slave token passing, what that stands for. It's a 2-wire cable that uses a master type application where an address on the bus becomes the master, passes the token over to another, that one then becomes the master, and so forth and so on, goes down the line. Very similar to a wireless mesh system with wire. It's the same kind of theory per se, where one device is going to be the deciding device on the network and then passes the information to the other, and it eventually gets back to a hub or a web server. Okay, and so that information on the web server then collects that, and now you have the opportunity to look at that system through a web browser, or it might be a touchpad or whatever it might be. It could be an app on your phone, that type of application. Now you see everything, right? The difference here is this is an owned, or what we would call an owned system, which means whoever the vendor is that's providing this is going to provide an open protocol system. Hopefully it's open protocol in either Bacnet or some LAN is still available a little bit here and there. Modbus is still somewhat available, but mainly right now it's Bacnet. So you're going to have a Bacnet system that is owned by the purchaser of the system, whether it be the building owner or a management system or a management company, right? Schedules, set points, alarms, all of the maintenance, all of the history, reporting, the connectivity and all that is done by whoever manages that building, okay? Then there's the cloud-based systems, right, where you're going to have thermostats, again, all affordable thermostats that go to some type of a hub, and that hub then connects to a cloud that is managed by a provider. So a cloud-based system, all the schedules, set points, alarms, all of those things are in the cloud. So it's typically a service charge or a monthly charge or an annual charge in a lot of cases. That is done through the provider. Very few systems that are cloud-based do not have that type of a capability where their provider is involved at all times in that system. And you're seeing a lot more systems go this way. Even on the DDC front, I think you're going to start seeing more systems where the cloud is going to be used more than a server. And it's just the way that the nature of not just our business, but a lot of businesses are going to internet-based solutions. Service as a support, or support as a service is one of the terms that you hear a lot. Okay, so but you keep that in mind. So a cloud-based system, you're still connected to some provider. It's not necessarily owned by the owner or the operator of that building. Okay. So some of the things that are changing in our market in this application, right? Again, it's a lower cost application. You're not buying a controller per se by an individual vendor. You're buying a solution by a solution company, a controls company that provides solutions, which is a nice thing. So you're not stuck to a vendor, right? So I can have thermostat A in room 1, I can have thermostat B in room 2, completely different vendors, completely different applications. Maybe thermostat 1 is a standard rooftop. Thermostat 2 in room 2 over here might be a hot water system. Maybe I've got a hot water heater that I want to control, and I want to take a look at the temperatures around the piping or something like that. And instead of putting a DDC controller out there, I'm going to put a remote sensor on the pipe and do some things like that. Room 3 might be a different type of an application. Maybe it's a fan coil that has a chilled water or a hot water heater valve in it, something like that. So I want to use a different thermostat for that. And, room 4 is something else. Maybe I can use a different thermostat there. So I've got capabilities within the applications that I can change the application based on a vendor's product. I'm not stuck to a specific vendor for an application, which is a nice thing in our day and age. Now a DDC system is not necessarily a one owned one shot system. You can mix and match, right, with the protocols that are out there nowadays. Right, so that's a good feature of having let's say a wired system versus a cloud-based system. Is a wired system can use this type of technology because what we're doing is we're taking the Bacnet objects or the integration points from each one of these controllers, whether it be a DDC controller in a larger application or a smaller, lighter application, and we're integrating that to a front end. Okay. In a cloud system, I can't do that. The cloud has to be looking at its internal type product. I might be able to do it with different Zigbee or different InOcean products that work on the same cloud. Most of the time, you're not going to be able to mix and match in that regard. Okay. Some of the things that we're seeing in the future too, and this is more from we're talking about low cost, right? So what costs a DDC system? It's not just the product. Usually the product's about a third to half of the cost of the system. It's the installation of the system, right? When you get into DDC systems, we're talking about light DDC. A lot of it's installation. What makes the cost go down from the installation of that system and how we're going to provide it? One of the things that we're seeing change from a lot of vendors is what we call IP topology, right? So the way a IT infrastructure works is, somebody's going to run Ethernet cable out to these rooms, like I was showing on the last slide, because they're going to need internet connectivity to the switch in that building, right? And it can be an unmanaged or a managed switch. Unmanaged means that we're going to have a switch that is not necessarily connected to IP addresses as provided by a service provider. We might create these IP addresses. We might create a private IP network using an IP exchange that's private. And so these controllers can sit on that private IP and go back to a switch. And then from that switch, we might send one IP over to a managed switch, okay? But the nice thing about this is, and what we're seeing that could be a capability in the future, which will be a capability in the future, just don't know when yet, is that working directly with the IT infrastructure folks, why not run a cable in the wall to the thermostat? So now we have a cable, several cables in the, to a junction box, 2x4 in the wall, so that somebody can plug their computer in. Well, why not just run another one to the thermostat? And so they're handling all our wiring for us. They're already doing it. Why not handle it on the thermostat side too, or on the DDC side? So now we can have topology that allows us to bring what we would call Bacnet over IP into a switch or into a network. And we have all that data already there for us without having to be above a ceiling, run more conduit, all that type of stuff for our connectivity method, right? And this would be kind of a method topology for IP infrastructure, Ethernet data in a managed switch. Okay. So just some things that are happening that allow, again, the thermostat world and the DDC world to connect a little easier in the infrastructure of a building. Okay. So we're talking about light DDC, and the first topic we're talking about is thermostats. What's the difference, and what are some of the differences between a true DDC controller per se and some type of either Wi-Fi or connected thermostat? So one of them might be the I/O, the inputs and outputs that are readily available on a DDC controller. Most vendors are going to have expandable controllers where you're going to be able to look at 16, 12, whatever the magic number is of inputs, sensors, temperatures, humidities, dew point sensors, pressure, those types of things. And then a certain amount of outputs to do control on a DDC system, where a thermostat only has so much. The back plate of a thermostat's only so big. You can only fit so much on a wall. How much wire do you want to have down a wall? does that wire need to be separate? You know, we've got 24 volts going to a piece of equipment. Now I'm going to run a little 5-volt sensor. Yeah, I can't put it in that same cable. I've got to be careful when I, go up the wall to separate it. Those types of things. Where in a DDC system, I'm in a panel. I can put separate conduits and things for those types of applications. Right? So that's one of the things that makes it different. The thermostat might not be able to do specific functions. For instance, an integrated economizer. Now, there are thermostats out there that will control an economizer with an analog output, something like that. But looking at all of the factors that control for an economizer, dew point, the amount of outside air, airflow monitoring, those types of things, you're not going to have that capability in a standard thermostat or even a DDC thermostat, right? Preheat control. I may not be able to control a preheat coil. If I've got a chilled water system, I might be able to control the hot water in a reheat position, but I probably wouldn't be able to do both out of a similar thermostat or the same thermostat. A thermostat may not be able to handle multiple stages. Of course, in larger applications, we may have to go to a DDC controller instead of a thermostat for the several stages of cooling or heating. Again, just because the size of the thermostat capability in that small packet. Okay. And then keep this in mind. We talked about it. If you are using a lighter DDC application for a function, whether it be, let's say it's barred units or through the wall equipment, things of that nature, every one of those thermostats needs to be brought into a front end. And in order for them to be brought in through a front end, it has to have some kind of a Bacnet protocol conversion. So something has to sit on that front end that says, okay, I'm going to take the Bacnet information out of this thermostat and bring it into a web server. So somebody has to do that. A company that's providing that has to have that knowledge and that technology to do that in all those applications. Or it can be done through a cloud, which is owned by a service provider, not necessarily the owner. So those are some things that the thermostat DDC world has in store for you. Okay. For a DDC system, of course, the controls are versatile, right? There's a lot of adaptation to multiple applications, and multiple I/O allows that, right? So that we can have a panel controller that might do 90 points of control. So you've got lots more opportunity for specific applications and multiple applications coming out of one panel, right? The other big thing, again, is DDC systems usually, whether it's Trane or Carrier or York or Johnson or whoever it might be, they're going to have a product that talks directly to their front end. So the integration side of it is somebody else's stuff that might come into play. But if it's a DDC system sitting on a network connected to that DDC system manufacturer's front end, even if it's Tritium, which Tritium is a company that makes front ends for multiple vendors, there's very little integration. Those drivers and everything are already built in to the system, where in the DDC thermostat world, it's all integration. Some of the products that we've been using and some of the things that we've seen in the market out there that allow for, I'm not a big plug and play guy. I really don't like that term. Being in this business a long time, nothing's plug and play. But as close as you can get to getting something off the shelf and having it work out of the box without having to do a whole lot of programming. And when you do the programming, it's easy, web-based or on your phone applications that you can download on your phone or on your computer that make it easy to program. This is one of them. It's called Verisys, and it's a very light application system, but it can go up to 20, 30 ton equipment. Really, it depends on the application and what you're doing with it. But it handles stage modulated control. This is where we're talking about, maybe you didn't have the ability to do reheat and preheat. Well, this system would do something like that for you on an air handler or a split system application, that type of thing. What I really like about this system is not only is it easy to use and out of the box, but everything is in the product. So if I'm just using constant volume units, regardless of what type of an application, split system, rooftop equipment, that type of thing, I've got a hub that I can bring all this stuff in and they all look the same to me from an object standpoint. Everything that comes into this hub is easy to manipulate and easy to make graphical and those types of things. So it's a nice application. The other thing that's nice about it is it allows constant volume and variable air volume zoning to be more affordable in the market too. And everything ties back to this hub. Okay, it's easy setup. Some of the things that we've looked at is, just spaces where you have maybe a foyer area or an open area or a conference room, things of that nature where we can add on zoning to a standard thermostat type of a system without breaking the bank. And it's just a really easy application, both in a constant volume zoning system, variable volume, or variable temperature control system that allows us to do some things. Independent control, airflow pressure independent, it's standalone, right? It can use the hub or it doesn't have to use the hub. You can use the sensors as your front end if you want to. Supplemental heat options with hot water capability, has a nice balancing software built in that allows a balancing contractor to do a good job on balancing the system. And then again, the front end is the hub, or it can be sensor controlled. So no cloud, you don't have to go and pay a service fee or anything like that to make the system run. So it's a very nice system. You want more information on it, please let me know and we can work with you on these smaller applications. Okay. So again, light commercial zoning control without the huge price tag. Right? What about other applications? So rooftop units, split systems, those types of things. Thermostats and a lot of the vendors that are out there now providing these thermostats give us a pretty wide array of applications from those thermostats. But what they don't do are the systems that we run across all the time, as you all well know. We just did a fairly large facility for FedEx, where they needed a bunch of lead lag. They had to have cooling in specific areas if something went down. So we had to do a bunch of lead lag control on different types of equipment in the facility. There's a lot of applications that you run into. Again, you can throw a big DDC system at it, or you can make it a standalone application, single panel control with DDC controllers that have the number of IO that you need to do and the ability to do a light front end to see it. Okay. So basically it provides low cost monitoring control. Let's say, it's a chiller or something in a small plant that we just want to look at alarms. We want to do something with those alarms for that application, send something out, whether it be an email or some kind of a notification to somebody if something's going down or when something's getting close to going down, right? So maybe an IO panel controller that might have a display on it, might not have a display on it. Freezer and coolers. We're doing a lot of this now in schools that we don't have DDC controls in. The school has maybe PTACs through the wall units that have their own thermostat. Some of them are tied to a DDC or an EMS system where we're enabling or disabling them or setting them back and those types of things so somebody doesn't leave the thing on when the school room, classroom is unoccupied. But in these applications where they don't have either the budget or they don't have the application, the money, the dollars in the budget to do a full school application, we can just look at freezers and coolers. We can look at their kitchen, make up air and exhaust and things of that nature and put something in that's affordable and available for them to look. And again, from alarm standpoints, to see if something's going on in the freezer or see if something's going on in the kitchen that's not making sense to them. Some simple things like that with easy IO controllers. Small plant applications, we talked about that a little bit with chillers and boilers. Then again, lead lag and lead standby controls, just to have a panel out there that does nothing but that, but goes into either directly into a front end, directly into a web server, right? Because when we talk about front ends, we're seeing a lot of the control industry moving away from software per se. If there's software, it's going to run in probably a touch device or something like that that's physically connected to a panel or physically connected somewhere in the building. That's where software comes in. Software is no longer on a PC in the DDC world. There are still vendors that have software, but most of it is designed into a web server or it's plugged into a web server that you buy off the shelf. Okay, so a lot of these things can be, depending on, I don't know if you know the term Nook. There's some things that you can buy, the little computers, little mini computers that you can load software in or load server software in that run independently of a PC. And the PC just hits a website or hits an IP address, internal or external to the building. And now you have access to all this information that we're doing with these light controllers. Okay, so there's a lot of that application out there. And then there's touch devices that are programmed and integrated as well. Okay, so something like this where we'd have a number of control outputs, a number of monitorable inputs on a device. We'd have either an optional touchpad or basically up to a server to do some specific monitoring, basically plant alarm monitoring, lead lag, just simple temperature and humidity control. We've been doing a lot of warehouse applications lately where they can't get their equipment to run across the floor, especially with heavy, forklifts and things like that with a heavy load because of moisture on the floor. And so we're doing moisture control, looking at the actual floor moisture and bringing on fans to sweep across the floor and things of that nature without having to have large equipment in there, big makeup air units and stuff. Of course, that'd be the optimum way to go. That's just a big way of getting some type of control in a facility where there's not a whole lot of cost involved, and some smaller industrial applications where we're doing some things as well. Okay. Integration. So integration is a big word. It can be. In most cases, integration is just adding a web server, and it's really dependent on the integrator. So it comes down to who is going out there to fill this web server full of information, right? That's really what it comes down to when we're talking about integration. So there's going to be a web server out there. We have to have something that is going to provide access, whether it be graphical, whether it be line by line, whatever it might be, to an application. So we're talking about light DDC, right? Integration to bigger projects and things like that. Yes, there's a lot of time and labor involved, but when we're talking about light DDC, what we want is easy access to the integratable points of control from a application or from a piece of equipment. So we don't need servers that are handling an entire school campus. What we need is a small server. And so there are a lot of opportunities out there to get servers that don't connect physically to anything. There is no physical connection to a piece of equipment. The server can just be an integrator. So it's really like buying a CD or a disc from a vendor and popping it into whatever server you want it to be, whether it's one that's on site already or one of these Nooks we were talking about, where you can plug that software in there. And now you just have an access to something, right? What that something is you have to have some kind of a multi-protocol converter. You have to have a vendor that provides something that allows devices, whether it be through Bacnet Mstp, a 2-wire cable, Bacnet IP, which is an Ethernet, right? Or some type of a cloud-based or Wi-Fi type enabled device that gives us access either through a touch display or maybe an app on a phone, something like that, to where we can see this information, go straight to the server and get that information through what we would call transceivers or integrators, okay? That said, that device, that multi-protocol converter, has to have a certain amount of memory in it, and it has to be able to hold or store this information from a controller. So what are these controllers? What comes out of the factory already that allows us to see these things? So if we apply a integration application for a customer, what are we going to see? Well, some of the things that we can do. So for instance, let's go back to schools. If it's a area where the school doesn't have budget for a lot of DDC to take over a lot of applications in the facility, they're okay with programmable thermostats, they're doing the things that they need to do to be energy efficient, that type of thing. Still have to have outside air, still have to bring in ventilation for the facility. It needs to be controlled airflow. And so you think about ERUs and ERVs, and I'm sure the folks with Holden are going to be talking about some of the things that they have as well. Most of that product has the capability to communicate out of the box. And so to take that information from just the common areas of schools to do dehumidification or to look at the dehumidification, monitor it, apply it, shut it off when you don't need it. Those types of things, send a set point to it, change the set point based on ambient conditions or indoor conditions. Those are some things that we've been doing with just integrating to equipment that's already out there. Okay, and there's some things that are available, very inexpensive, very easy to do. It's just a matter of having the vendor with the capability of having communications in the product already, which most do. VRF. So in VRF applications, and again, VRF is we're talking about light DDC. Well, VRF's not the least expensive installed product. However, it's one of the most efficient, if not the efficient, product, especially for specific areas and specific applications. It is a very efficient system. We've done systems where we've gone into a building that has VRF already, that's not on a web server, no one's looking at it, it's just a VRF system standalone, and just put a server in and bring all the information in from that VRF system. It's had a Bacnet card right out of the box when it was put in. Nobody even knew it. We went in, just brought it in, started looking at the information, started finding problems in some areas and finding areas where we can do some improvement, things of that nature, not in mainly just giving the owner a fresh look at their system and what's happening in the building. And so just some simple things that we can do with VRF systems. Just about every VRF manufacturer gives you some sort of a protocol to allow you to see certain things about their system and write to certain points of information on the system as well. So it's just a matter of going in, seeing what we can see, and making adjustments as we see required for the operation of the system. Generators and boilers or hot water systems. You can look at domestic hot water. Now, just about every domestic hot water company, not everyone, but a lot of them do provide you some type of a communication interface for that. All generators do. Generators come out with Modbus as their protocol right off the bat. So we could look at a generator and make sure that it's operating properly, make sure it's not going to go down when you need it for alarms, things of that nature, just by having a server that's connected to that protocol. Standalone chill water, we talked about that, maybe some small power processing plants out there that we can be looking at. A lot of chillers come with multi-protocols as well as power devices, right? Metering, those types of things. If we just want to put a meter out there and look at what's going on with the building and then share that meter information with somebody so that we can be looking at, future capabilities of this building to save energy, those types of things. And then lighting systems. A lot of lighting vendors now have Bacnet. It has to be ordered separately, usually, and it takes some planning up front to make sure that they have the capability to give us what we're looking for lighting. But we've done some just standard lighting systems without any HVAC connected to it. The HVAC came later after we're saving them some money with their lighting applications through scheduling and things like that. So there's some things you can do with the lighting vendors as well. We talked about metering. And then lastly, hotel room integration. Right? So there are many systems out there now that provide product that already goes to a front desk system, something like that, to where somebody checks into a room, the set points automatically change on the thermostats and those kinds of things. It's almost kind of cloud driven to the standpoint where it's just the control point of it. You don't get alarms, you don't get history, you don't get a lot of that information from those systems. You just get a functional, setback occupancy system. That's basically what you get. So if you want other things in those systems, we can put a server out there and grab that information to do other things with the system. We can look at alarms, we can schedule things a little bit differently. There's lots of little things that we can do in a hotel room, start bringing in the common areas, that kind of thing, just to help save energy. And if it's a chill water or a water source system where we're doing some condenser water cooling or something like that, we can bring that in as well. So a lot of things we can do with that type of application. So not just having a controller that has I/O, is part of DDC Light. We could be doing the stuff through the integration with vendors that already have that control in IO. It's just a matter of bringing those, what we call objects of control, into a server, into somebody's fingertips so that they can go in and make changes and monitor and see what's happening with the system. So just a couple of options for a lighter DDC application where we're talking, cost effective, energy effective applications without having to get into large base DDC. A couple of things that have changed in our market again. There's a lot more thermostat per se type applications that can do a lot more than they did in the past, kind of to compete with the DDC type applications for split systems and rooftops and things of that application. And then web servers have gotten a lot less expensive. The front ends of systems now are flexible to where you don't have to buy a $50,000 front end in order to do DDC. You can buy simple, $2,000, $3,000, $5,000 front ends that do a lot, that can handle a lot of applications just by knowing how to provide those applications. That's really the key. All right. So with that, I'll take some questions if anyone has them. And again, I appreciate everybody's time today.